today what I'd like to talk to you about how Azure IoT Hub works, okay? So in essence, when we talk about IoT and the devices that we're using, they're not your typical devices like a mobile phone or a tablet or a laptop, right? And what they're designed for is to respond to sensor activity, whether it's in equipment or a break glass sensor or whatever that happens to be, whatever that IoT device is being used for. It's meant to use for those specific communications, whereas the typical device would act kind of like a server where it's waiting to receive information from everywhere, and it can cause some security threats if it's deployed in that manner, right? So we use firewalls and all the kinds of software and other equipment to try to protect our equipment. But the whole idea with IoT is that these low power sort of, almost a no frills device is what's deployed. So you don't have a lot of that capability, right? And the traditional PKI trust model is kind of inefficient and ineffective for the IoT model, right? The TTL, or time to live, of certificates is just too long. It just doesn't make sense for these devices. And by default, promiscuous mode is turned on, which kind of defeats the purpose, as we're trying to have a secure environment. Azure IoT Hub implements a service-assisted communication pattern or methodology, however you want to look at it, right? Where this methodology mediates interaction between back-end systems and devices. So you have a bidirectional, trustworthy communication setup, and you're taking security first. That's the number one priority of this configuration. Devices will not accept unsolicited information. They must regularly check in for instructions, right? And authorization is based on a per device identity for fast revocation, as opposed to allowing things like broadcast and those types of messages, right? For devices that are in areas where you have network coverage issues or power issues, IoT Hub provides queues for the messages that go, are set up for communication with the devices. And, in essence, it'll hold the message and then it'll validate the device and before anything gets sent or received from that device. And after it's validated, we'll send and receive the data that's necessary. This also sets up an application payload data, which is secured separately, right? So any data that's flowing through is going to be secured for protected transit through the gateways. The data is wrapped prior to sending and receiving to and from devices, right? And devices can work peer-to-peer before they actually get to a gateway, so to be able to extend out the range. But they have to be configured to do so, and the devices have to be able to work amongst each other. And again, that gateway is what communicates with your IoT hub. Now, this is also designed with the assumption that devices are deployed in a reasonably secure local network, okay? The key word there being local, right? So local networks generally have basic protection like anti-flooding and anti-brute force attacking mechanisms in place that can help you to ensure the security of your devices, that they aren't compromised. And all that traffic is designed to flow to and from the gateway, and then, as I mentioned, that then communicates with the Azure IoT Hub, which you can use to collect the data for big data uses or setting up Power BI reports. A lot of different options there once you have that data collected. So here at Pragmatic Works, we love playing with this stuff. We love Microsoft Azure. We love IoT. And we welcome any opportunity to help you out with it. So if you have questions or you'd like some help, please click the link below and we'll be happy to get back to you as soon as we can. Otherwise, have a great day. Thanks very much.